Hi, today I'm going to make a song recognition algorithm, and using it, we will identify songs using fragments of them. So this is how recognition works. We look through a database of many different data samples and find the correct one based on their matching features. But in our case, looking for every frequency in every song in our database could be disastrous. So to make it quicker, we are going to use a technique. And the technique we are going to use is called audio fingerprinting. This technique works by identifying a song just by looking at its meaningful data. And by meaningful data, I mean pattern. Look at this graph. A normal person cannot just store every detail of this graph in his head. And that is true because human mind could not process too much data in a small period of time. But there's something which he can store easily, and that is pattern. Or to be more specific, peaks. And if I show him fragments of this graph using the peaks, he could easily identify it. But one thing that makes the person identify the graph easily is not only the peaks, but also the distances between them. So we take advantage of this for identifying audios. The process we are going to use is pretty simple. Find the difference in distance of the peaks, create the hashes of it, and search for the hashes. Wait, but what if there are too many frequent peaks? Isn't the data for search going to expand? Surely it will, but there's a solution to that too. That is setting a limit for minimum distance difference that we can take into our account. And next, for distinguishing peaks with flat data, we are going to look at the gradients at 2 points in the frequency array. If the gradient is too high, it's a peak. If it's not, it's flat or not enough for our data. And the next thing we are going to do is to hash that data. Hashing basically creates a unique fingerprint of the data, which makes it faster to search. So for every certain time interval, we create a hash of next n difference of distance of peaks. So we can search for fragment of song from any point of the original audio. Let's see a working example of this algorithm. So here are 4 MP3 files numbered from 1 to 4, and from 2 of them we have taken 1-second clips, and we are going to find from which of the original MP3 files does this clip belong to. And here we have the correct results. Let's look at the code. This is the preprocessor, but it's actually the most important part. It removes all unnecessary data, basically by doing the frequency gradient thresholding and calculating distances in the peaks. And one more thing, the frequency array we get from a parser is in small decimal values instead of being in integers. So we have to multiply them to start processing. It works just like how I explained to you. Rest of your code is just normal hashing and MP3 file parsing, so I'm not going to explain in this video, but yeah, thanks for watching, and subscribe if you want to see some cool 3D neural network stuff in the future.